Okay, I will read today some best design world-class system value and UVM training. The SNOG 2018 was also voted best presentation second place. The title of this paper is UVM analysis port functionality and using transition copy command. The abstraction I will. There is significant confusion surrounding UVM analysis port and a similar confusion about the UVM transaction copy command. Many verification engineers who consider themselves to be UVM expert can easily spend hours debugging analysis port issues if they are unaware of important consideration related to the analysis port paths. This paper explains the UVM analysis port uses and compares the functionality to subscribe satellite TV. The paper shows simplify the non-UVM analysis port implementations to clarify how the corresponding UVM port connections work. The paper describes how the analysis port write method efficiently calls each subscribe write method. Part of the explanation describes when an analysis implementation port requires the use of a transaction copy command. The paper describes the problems that arise when multiple analysis port implementations are required in the same component and how to address the problems. The paper also describes an example of how improper handling of transactions can hide design test bench bugs. The example shows how a bug was hidden in a scoreboard that went unnoticed for months and took hours to detect and fix once we identified that there was a problem. Okay, this the let me see the let me check let me read the table of contents. Chapter 1 is the instruction satellite TV example. 2. Observer pattern and analysis path pages. 3. UVM port fundamental. 4. Chapter 4 is the UVM analysis port and export and IMS. That's 5. Declaring and constructing porting and TLM FIFOs. And 6. UVM subscriber. 7 is the system value mailbox. 8. TLM FIFOs. 9. Backtick UVM analysis in particular SFX macro. 10. Example with the typical analysis copy problems. Summary 11. Summary and conclusion. 20 is acknowledgement and process. There are many figures, tables and tables. Okay. Actually, I will quickly read the introduction of satellite TV examples. Those familiar with the satellite TV know that the programs are broadcast as schedules. The viewer either needs to watch the program live as it is being broadcast, or they need to set up a digital video decoder (DVR) to record the program for later viewing. The seller will broadcast the program as scheduled, whether there are thousands of viewers or no viewers at all. The broadcast has been scheduled and it will happen on schedule. If a viewer neglects to set up a DVR to record the desired program, and viewer turns the at TV on 15 minutes after the program has started, the viewer can request the satellite start over and rebroadcast the desired program from the start. For these two reasons. First, the viewer has no way to communicate to satellite to desire to restart a program. And second, the other viewers object to programs being restarted while they were watching on a program live. It should also be noted that the viewer of a live broadcast cannot modify the satellite version of the broadcast program in the real time. If the viewer has the right equipment and the software, the viewer might splice the recorded program or censor unwanted language and content, but those added to have to be done on the local copy of the program and do not on live satellite broadcast of the program. The UVM analysis port underscore the UVM underscore port as a broadcast port are very analogous to the satellite TV examples. Since UVM analysis paths do not broadcasting the transactions over the airwave, it is instructive to understand how classes are assembled to allow a new subscriber to be added to an analysis broadcasting source with a little modification to the existing environment. Despite the fact that viewers of a satellite program do not modify the broadcast programs, engineers are frequently guilty of modifying the original transaction, and such modifications can cause subtle problems that are difficult to debug. This paper will show many analysis features that engineers should consider when using analysis ports. Okay, chapter 2, the observer pattern section. Hmm, chapter pattern and analysis path basis. The UVM analysis path is an example of a software design pattern known as the observer pattern. Observer pattern and definition. A concise definition of observer pattern is found in Wikipedia. The observer pattern is a software design pattern in which an object called the subject maintain a list of its dependent called observers and notifying them automatically of any state changes and usually by calling one of their methods. Okay. 2.2 A simple system value analysis path examples. We found that most examples of analysis paths are very complex and difficult to understand. The multi-part scenarios shown in these sections are an oversimplification of the analysis path implementation and system backlog, and are fully UVM compliant. But their simplicity make them easy to comprehend, and being simple allows engineers to have a conceptual understanding of how the UVM underscore analysis underscore path works. Four scenarios will be presented to demonstrate how analysis paths observer patterns work. In all four scenarios, the transaction analysis if and subscribers remained unchanged. Also unchanged is the fact that the tab module declares all of the subscriber handles and has to new construct each subscriber. The tab module in the cache each scenario will show important differences after the subscribers are constructed. Scenario
Differences are visible in the monitors and the latter part of the top modules. The first scenario, Monitor 1 has declared all of the first scenario, Monitor 1 has to declare all of the subscribers and call their respective write method by explicitly referencing the handle names. The top one module has to copy all of the constructed subscriber handles to the monitor one subscriber handles, which require the top one module to know the internal handle names of each subscriber. In the second scenario, monitor 2 defines a connect function method for each subscriber so that the top two module only has to know there are connect methods without being required to know the subscriber handle names. In the two scenarios, first two scenarios, each subscriber required a separate declaration, separate call to write method, and the top module had to either copy each subscriber's handle name to the corresponding handler's name, not corresponding handle names in the monitor, or had to connect a method that was unique to each subscriber. Adding more subscribers requires lots of extra code. Okay. In the third scenario, in the third scenario, Monitor 3 has declared the queue of analysis underscore if handles and a common connect method that pushes a new handle onto the queue. The run task simply uses the for each loop to pull each handle off of the queue and call the write method defining each subscriber. From this point forward, whenever the top three module adds a new subscriber, no modifications will be necessary inside the monitor. This is possible because each new subscriber that extends the analysis underscore if must provide an implementation of the commonly named virtual write method. In the fourth scenario, subscriber 2 modified the transaction values and we observed that since each subscriber has a handler to a common transaction, that subscriber 3 sees the modified transaction and not the original broadcast transaction. This demonstrates why the subscribers should never modify the original transaction but should take a copy before doing any transaction modifications. Okay. Next section is scenario common files. The files in sections are common to all four of the subsequent scenarios. The transaction, trans1, that is passed around these scenarios has two randomized fields, address and data, and both fields. Though the post-randomized method automatically print each time the transition is randomized, the trans1 class is shown in figure example 1. Example 1, the transition class with built-in post-randomized method to print randomized transition values. Okay. A virtual analysis underscore if base class shown in figure 2 is declared. Is it a way to? I'm sorry. Okay. 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 Is declared with the fewer virtual write method Any class extend the analysis underscore if class will be required to provide right method implementation. In this example, there will be three subscribers that are extension of the analysis if class. This is similar in concept to a UVM underscore analysis underscore imp inside of a UVM subscriber. Since there is a pure virtual write method defined in analysis underscore if. Any class that extends the analysis underscore if UVM underscore subscriber is required to use the exact same prototype function header and provide the actual implementation. The implementation in this example will be simple display command to show the transaction that was received. Example 2, virtual in analysis underscore if base class and the pure virtual write method definition. Okay, next is for these scenarios, three subscribers shown in example 3 and 4 and 5 have been extended from the analysis if virtual class. All three have a write method implementation that displayed which subscriber issued the message and the current content of the transaction. Subscribe to in example 4 include bug code to modify the transaction when the simulation is compiled with defined bug. The behavior of the bug is described later in this section. Example 3. Subscriber 1 with the right method to do display. And next one, example 4. Subscribe to with the right method to do display, including bug testing code. Example 5, class subscribe 3 with the right function method to do display. Okay. So now 2.2.2 scenario 1, monitor 1 example separate analysis if declarations no connect method. And the first scenario, monitor 1 shown in example 6, declares the three analysis underscore if handles with handler names AP1, AP2, and AP3. The monitor 1 class also has a run task method that, when executed, will call AP1 write, AP2 write, AP3 write. Here, actually, yeah. Example 6, monitor 1 in separate analysis if declaration. No connect method. Okay, there are many. Oh, mhm. The top one module shown in that is example 6. Next is the top one module shown in example 7 declares a new construct. The monitor 1, subscribe 2, and 3 class objects. Then I copy the subscribe handles sub1, sub2, sub3 to respective analysis underscore if AP handles declared in monitor 1. Example 7. Have one module with a subscriber handles to copy the two AP handles in monitor 1. When the simulation is run, the monitor one long task calls the right method for each AP object. The simulation loops 5 times, repeat 5, each time re-randomizing the transaction. Monitor 1 then broadcasts the transaction, and each subscriber write method receives and displays the randomized transaction values. Each subscriber reprints the current contents of transactions since each subscriber has a handle to the same broadcast transaction. Okay, next page. The simulation results are shown in figure 1. See, the figure 1 is monitor and subscriber simulation output. Scenario 1 shows that a common transaction can be broadcasted. The, the multiple observers or subscribers. One problem with this scenario is that each time a new subscriber is added to a top 1 module, another analysis underscore if port must be declared in monitor 1, and the run task must add another call to the new analysis if write method. Of course, the top 1 module would also need to declare new construct another subscriber shop and copy the constructed handle to the new monitor 1 AP shop handle. Each new subscriber requires 2 existing files to be updated. In this scenario, top 1 is to know the internal handle names of each analysis underscore if. It would be better to have a connect method to make a connection hide the internal analysis underscore if handle's name. Okay, scenario 2 will add the desired connect method. Okay, 2.2.2.3 scenario 2 monitor 2 with a separate analysis underscore and connect method declarations. Okay, in the second scenario, monitor 2 shown in figure example 8 declares 3 analysis underscore if handles with handle names AP1, AP2, AP3. Monitor 2 has added a connect method for each individual analysis underscore if. This is class monitor 2. The example 8 monitor 2 with a separate analysis underscore and connect method declarations. It is starting to become obvious that the addition of each new analysis underscore if a subscriber requires the overhead of declaring of the new analysis if handle corresponding connect method to a core AP shop write function method write method. In scenario 3, all of these issues will be addressed. Example 9, top 2 module with calls to separate connect method. Okay. Top 2 module shown in figure example 9 declares new construct monitor 1 and subscriber 1 and subscriber 2 and 3 class of object. Then call the monitor 2 connect shop method to copy the handle sub 1, 2, 3 to respective analysis underscore if AP. Handles declared monitor 2. The top 2 module no longer needs to know the internal AP shop handle name. One problem that exists in scenario 1 still exists with this scenario. The problem is that each time a new subscriber is added to the top 2 module, another analysis underscore if port must be declared in monitor 2 and the run task must add another call to the new analysis underscore if write method. Okay. Scenario 2 also requires the addition of a new connect method for each new analysis underscore if handle. Of course, the top 2 module would also need to declare a new construct another subscriber shop and connect to the constructed handle to the new monitor AP shop handle. Each new subscriber still requires 2 existing files to be updated. When a simulation is run, monitor 2 run task calls all the right method from each AP shop object. The simulation loops 5 times, repeat 5, each time re-randomizing the transaction. Monitor 2 then broadcasts the transaction and each subscriber write method receives and displays the randomized transaction values. Each subscriber reprints the current contents of a transaction since each subscriber has a handle to the same broadcast transaction. The simulation results are the same as shown in the figure and shown in the figure 1. Next section is 2.2.4 Scenario 3. Monitor 3 with the analysis interface queue and common connector method. So scenario 3 solved the problem that required to modify the monitor 1 and 2 and in monitor 3 shown in figure 10, example 10. Unbounded queue of analysis if ports is declared. Analysis underscore if AP dollar. In monitor 3, each time the connect method is called, a new subscriber handle is pushback added to the AP queue. Also in monitor 3, when the run task is called, for each loop calls each of write methods for the queued subscriber handles. The class 3. This is the example 10, monitor 3 with the analysis queue and common connect method. These three improvements make it possible to add more subscribers without making multiple modifications to the monitor 3 class. This is roughly how UVM underscore analysis underscore ports and the UVM subscribers work. Now, the top 3, shown in figure 11, can now call a common connect method for each time a new subscriber is added to the design. Example 11, top 3 module with a call common connect method push subscriber handler onto queue. Next. Scenario 4, buggy example where subscriber 2 modify the transaction. In scenario 4, the simulation will, with the defined bug compilation, switches to force subscriber 2 modify the address and data field of the broadcast transaction. As can be seen in figure 2, after the subscribers modified the address and data field, subscriber 3 leads the field from the reference transaction handlers and displayed updated values. Subscriber 3 should have acted upon the original address and data field. Sub 3 sees corrupted transaction. Okay, figure 2 monitor subscribers bug simulation output. Broadcast transaction from an analysis underscore port should never be modified. This is why the transaction copy command is so vital to UVM test bench environment. The scoreboard predictor should make a copy of the broadcast transaction. Then it reads the copied transaction input to calculate the predicted output. The predicted output is then placed into copied transaction for comparison to the actual broadcast transaction. The original transaction should never be modified. The guideline here. Modifying fields of analysis port broadcast transaction should never be done. Okay. Next is UVM analysis port write versus UVM input write method. In this simplified example, each monitor has a run method that calls each of the subscriber write method. The UVM underscore analysis port calls an analysis, an analysis port write TR method to broadcast a TR transition. Each UVM analysis imp to find the right method that is executed when the analysis port called right method. There are good, there are pros and cons to this naming convention. Put right command actually leaves each UVM underscore analysis underscore imp handler and then calls the right method for each handler. The advantage to this approach is that an engineer only needs to remember that there is a right command that broadcasts the transaction and a right command at the end of each analysis path that is executed. This advantage to this approach is that engineers often mistakenly think the port write command is an actual call to the UVM analysis underscore imp write method. Sorry, again. Engineers often mistakenly think port.write command is an actual call to the UVM analysis imp write method. The port write method could have been named anything, including port broadcasting, as long as the command itself called respective subscriber write method. In short, port write is not the same as subscriber write method. The port write method calls the subscribe write function method. The port write command could have been named anything, but the developers of the UVM decided to keep the broadcast and implementation method named the same. Oh, exists. Okay. It's just chapter 2. Chapter 3, the UVM port fundamental. This is reading time. I will read the text. I will not explain the figure. 3. UVM port fundamentals. The UVM base class BCL includes base port classes that are extended to define the TLM1 transaction level modeling 1 ports that are used in the UVM verification environment. Section 3.1 UVM port connection change. UVM TLM connections include the change of ports, exports, and IMPS implementation. Figure 3 is common analysis port connections recommended connection. 3.3.1 UVM port. UVM ports initiate a transaction activity and can connect to one other UVM ports, UVM exports, and UVM IMS. 3.1.2 UVM export. UVM exports are basically transfer ports that can connect to one other UVM exports and UVM IMS. 3.1.3 UVM IMS. The UVM IMS implementation terminate a chain of ports and export and IMS. Only one. 3.1.4 Unfortunate port naming convention. Oh my god, what is that? An unfortunate naming convention inside a UVM makes the imp correction rather confusing. UVM documentation teaches us port connecting export and is what? Vague about the imps. sorry again. UVM documentation teaches about ports connecting to exports and is somewhat vague about INF. In fact, the UVM sequencer base class includes a sequence underscore item underscore exported handle declaration, but this so-called export handle is really a UVM underscore sequence underscore item underscore pull underscore input port type. Similarly, the UVM subscriber base class, which is frequently extended to help create scoreboard and coverage collector, has an analysis export handle declaration. But this so-called export handles is really an UVM underscore analysis underscore input port type. Oh, okay. 3.1.5 port export input chain. Most port export imp chains only allows a single connection point. The driver sequencer is a common example in a UVM where the driver port UVM underscore sequence underscore item underscore port connected to a sequencer export sequence underscore IM underscore export, which is really an implementation port. The broadcasting port type in UVM is the UVM underscore analysis underscore port. This port type is allowed to connect to the multi port export and imp chain, each of which must terminate with a UVM underscore analysis underscore imp. Figure 3 on page 15 shows two common analysis paths that are used in a UVM test bench. Okay, the common set of Figure 3 common analysis port connection, recommended connections. By the way, the common set of the paths shown in the figure 4, the first analysis path originate with the UVM underscore analysis underscore port on the TV underscore monitor, that broadcasts to another UVM underscore analysis underscore port on the TV underscore agent, which then branches into paths with the first path labeled path number 1 terminating at UD UVM underscore analysis underscore imp on the TV underscore coverage collector. The second branch from the TV underscore agent to connect to the UVM underscore analysis underscore expert on the TV scoreboard. The UVM underscore analysis underscore expert on the TV scoreboard then branches into two paths with the first path labeled path number 2 terminating at a UVM underscore analysis underscore imp port 2 on the SB predictor extended from the UVM subscriber. And the second path labeled path 3 connected to the UVM analysis expert on the SB underscore comparator, which then terminate at a UVM underscore analysis input on the UVM underscore TLM underscore analysis underscore 54 for the handler name 54 out 54. Figure 4 analysis path for the set of the three paths. The second analysis path is shown in figure 5 on page 9. The analysis path starts with the UVM underscore port on the SB predictor that are connected to the UVM analysis expert on the SB comparator and terminates at a UVM underscore analysis underscore imp on the UV underscore TLM underscore analysis FIFO with the handle name EXP FIFO. Here, analysis path and second set of the paths. Okay, 3.1.6 UVM port to and export to interchangeable. The interesting fact about the UVM port and analysis and export is that they are largely interchangeable except for the originating UV underscore analysis underscore port that is responsible for broadcasting the transaction, replacing all of the UVM underscore analysis underscore export as shown in figure 3 with the UVM underscore analysis underscore just a port as shown in figure 6 does not change the behavior of UVM test bench. Replacing the export with non-broadcasting port just changes the type of the transfer type, so the simulation continues to run the same as it did in figure 3. Figure 6. Not recommended analysis export and no analysis export, but it works. Similarly, replacing all of the non-broadcasting UVM analysis port and shown in figure 3 with a UVM analysis export as shown in figure 7 does not change the behavior of the UVM. That's mentioned. Replacing non-broadcasting port with export just change the type of the transfer type. Just the transfer port. The simulation continued to run same as it did in figure 3. Figure 7, not recommended analysis export and one analysis port per analysis code source, but it works. Okay, 3.1.7 UVM port and export usage guidelines. We do not recommend randomly replacing export with a port and a port with export, since the practice is confusing to most UVM verification engineers. Guideline they use a UVM underscore analysis underscore ports for component outputs that are forwarding a transition to other ports on the analysis path as shown in figure 8. Figure 8, UVM analysis port recommended usage block diagram like here. Guideline. Use the UVM analysis export or UVM analysis input for component inputs receiving a transaction from the other ports on the analysis path shown in figure 9. UVM analysis export and IMS recommended uses block diagram. Here is ongoing transaction, here is incoming transactions. Okay, next section is 3.2.
3.2 UVM port base connect method. The virtual UVM port base class include multiple methods, virtual and non-functional, that are used to define the TLM1 port types. Among the methods in the UVM underscore port underscore base is a virtual connect method. The virtual connect method included 46 lines of code that performed certain important inspection to ensure that TLM connections are legal. The connect method includes functionality that examine the UVM test bench code to make sure that a UVM export is not connected to a UVM port. The port must connect to an export. Similarly, the UVM underscore port underscore base connect method check to make sure an UVM is not connected to any other port. The port or export must connect to a final IM. 3.3 Scope of port discussion in this paper. The full understanding all of the different UVM port types and how they can connect it and the methods that are available to pass transitions between components using TLM1 and TLM2 is beyond the scope of this paper. This paper focused on the use of analysis port chains, some of the underlying the implementation basics, proper use of method with the analysis chain. This paper also described common mistakes that are made with analysis change and how those mistakes manifest themselves in a UVM verification environment. The proper use of the transition copy method is used to avoid many analysis chain problems and is discussed in this paper. Now the UVM analysis put exports and IMS. UVM analysis UVM analysis path originates with the UVM underscore analysis port that broadcasts the transaction which can pass through one or more UVM underscore analysis underscore ports and or UVM underscore analysis exports and has one or more UVM analysis imp termination points. If a UVM analysis port connects to any UVM analysis export, then there must be an UVM analysis imp at the end of each analysis path chain. It is legal for UVM analysis port to connect to other UVM analysis ports without connecting to any UVM analysis expert or UVM analysis imp. This is analogous to a satellite broadcasting when nobody is watching or recording the program. The satellite does not query to find out if anybody is watching the broadcasting program, and the UVM underscore analysis port does not query to find out if there are any UVM underscore analysis imp termination point on the UVM analysis path. Details of different port types are described below. The 4.1 UVM analysis port 2 broadcast port 2. As already noted, the UVM underscore analysis underscore port 2 is a broadcast port that broadcasts a transition from the port until it reaches to 0 or more UVM analysis imp ports where the transition is either used immediately in 0 time, or a copy of the transition is made so that the copy can be manipulated over time without modifying the original broadcasting cast transaction. This is why the transition copy command is so important. A UVM analysis port can be connected to other UVM analysis ports, exports, and IMS, but there is only one UVM analysis imp per analysis path. 4.1.4.1.1 Why the transition copy method is so important? Any component that needs to use the transition over multi-cycles must take a copy of the transition because the broadcasting transition can be changed at any time, and there is no way for a component to communicate with the UVM analysis port to hold the original transition. Any component that needs to modify any field of the transition must also take a copy of the transition because there may be components that are fixing the broadcasting transaction. Therefore, Modifying the field of the broadcasted transaction will cause problems for other subscribers that needed to access the original transaction content. Even if there are no other subscriber, a component should take a copy of the transaction before modifying any field, since another component might later be added to the analysis path and would rely on an original unmodified transaction. Okay. Next one is for that too. UVM analysis export to transfer port. The UVM analysis expert is a little more than the transfer point connection between the broadcasting UVM analysis port source and each UVM analysis imp termination point. UVM analysis export can be viewed as a transfer port. 4.3 UVM analysis imp termination port. UVM analysis imp provide required right to method implementation to terminate a UVM analysis path. The verification engineer is required to override right method with an implementation for UVM underscore analysis imp. The port export imp confusion 4.4. When it comes to the behavior of ports, exports, and imps, there is a great deal of confusion surrounding these names. Ports initiate activity by executing commands while exports and imps are target of the commands and actually provide the implementation of the commands. For many engineers new to transaction-level modeling, this seems backward. Many believe that the initiator is the expert and the target should be the port. What is the reasoning behind these names? This can be the best described with an example. The 4.4.1 driver, car, port, expert. Every car has a steering wheel. When the driver turns the steering wheel in the clockwise direction, the car turns to the right. When the wheel is moved to the counterclockwise direction, the car turns to the left. The driver does not exactly know if the steering is compressed to the rag and the pinion steering, a power steering by the wire, or some other mechanism. The driver just knows how to turn to the steering wheel to make the car turn to the right or left. Every car has an accelerator pedal. When a driver pushes on the accelerator pedal, the car will accelerate. When the driver lets up the pedal, the car will coast and slow down. The driver does not know if the acceleration is accomplished through a carburetor, fuel injection, or some type of electric motors. The driver just knows that pushing the accelerator pedal will increase the car speed, while letting up the pedal will cause the car to coast and slow down. Every car has a brake pedal. Mhm. When the driver pushes the brake pedal, the car will slow down and stop. When the driver lets on the brake pedal, the car will start to move and can now be accelerated. The driver doesn't know if the braking system uses disc brakes, the drum brakes, or some type of electronic recovery and battery charging system. The driver just knows that depressing the brake pedal slows the car and bringing it to the stop. Then, releasing the brake pedal allows the car to go forward again. In each of these scenarios, the driver issues the command but does not have the ability to execute any of the desired described actions. It is the car that must export. Sorry, again. In each of these scenarios, the driver issued command but does not have the ability to execute any of the described actions. It is the car that must export to the driver the capabilities that the driver will control. But it is the car that has the actual implementation of each of the required function. Similarly, the car cannot execute any of command autonomously, but must wait until the driver initiates the appropriate command. The driver is the initiator port, while the car is the target export. Note: the driver cannot successfully issue any command that is not executed by the car. The driver might try to place a hands-free call over the automobile Bluetooth connection to the driver's mobile phone, but if the car does not export the Bluetooth phone control capabilities because it is not a feature of the particular car, such a command by the driver will fail. The driver can only issue command that are exported to the driver by the car. This is what happens with the TLM connection. The port can only execute commands that are exported by the connected export or imp. Okay. 4.4.2 Export and imp confusion. The UVM documentation describe all connections as port and export connection, but in reality, it is an imp implementation export that provided actual exported functionality. Two examples found in the common UVM testament include driver SIG under item underbar port connect to the sequencer SIG underbar item underbar export. SIG underbar underscore item underscore port as just the handle name of the UVM underscore SIG underscore item underscore pull underscore port. Just port. SEQ. SIG underscore item underscore export is just the handle name of the UVM SIG item pull input implementation. The UVM subscriber component has a built-in analysis underscore export, which is really just the handle name for the UVM analysis imp. The UVM documentation seemingly tried to hide the existence of the imp by giving a export handle names instead of imp handles names. We personally believe it is mistaken to declare the imps with the export handle names, but that is how the UVM base classes are defined, so an engineer just has to understand this naming inconsistently. Ha ha ha. Okay. 5. Declaring and controlling ports of TLM5. TLM5 is an important component that is used for test bench synchronization, especially in a UVM scoreboard. TLM5 are built from the system Verilog mailbox. Mm. TLM5 was built from the system value mailboxes. Mailboxes described in Section 7, and TLM5 was described in Section 8. Portion TLM5 was a UVM-based classes that are registered in the factory and are used directly in a UVM test bench. Because they are not registered with the factory, because they are used directly. They are new, constructed, and not factory turbine integrated. 5.1 How are analysis ports and the TLM5 are declared? The declaration of the different analysis port types has a subtle difference. Subtle difference. An example: UVM analysis port is declared with the transition type parameters displayed near the top of TV underscore monitor class shown in example 12. Sorry again. An example: UVM analysis port is declared with the transition type parameter displayed near the top of the TV underscore monitor class shown in example 12. The declaration requires the transition type parameter. In this example, the TV monitor broadcasts the transaction using AP write command in the run phase. Okay, TV monitor and the monitor, UVM underscore analysis port, and AP is in build phase and build write in the run phase. Okay, this is an example 12 TV monitor with UVM analysis put declaration and the AP write command. Okay. The example UVM underscore analysis export is declared as the transition type parameter displayed near the top of the TV underscore bold class shown in example 13. The declaration requires the TB transition type parameter. The UVM analysis export is typically connected to other UVM analysis ports and UVM analysis exports and possibly one UVM analysis input. There are now methods that need to be executed to propagate transactions on the UVM underscore analysis underscore export. This is the example TV underscore scoreboard UVM analysis with the UVM analysis export declaration and connection to other analysis type export. Okay, next one. Here, there is a TV scoreboard, UVM analysis export, and AXP. AXP is analysis export. An analysis export is built in the build phase, and an AXP connected to analysis PRD export, and and also AXP connected to CMP, AXP out. In this example, the export this a analysis export connected to the PRD predictors analysis expert and also CMP competitor to AXP out. Okay, here the UVM analysis input, unlike the UVM analysis port and the UVM analysis export declarations, is required to declare the two parameters, the transaction type and the class name. An example UVM analysis input is displayed near the top of the SB predictor class shown in figure 14. The declared UVM analysis input
must be built-in and must override the right function method provide required implementation. In the example 14, the XDPredator with the UVM analysis input, declared declaration and the right method class SB underscore predictor extends the UVM component. There is input. This is a predictor, and as I told you, it has as it was described. There is type. There's type of transaction type, and the class name, and it is analysis expert. In the filter phase, it is created, and in the function line as a result underscore AP. Result underscore AP is here. This is analysis port, and the writer the export TR. This is access port. This is the analysis port. And now 4.2 as well the TLM ports and the TLM FIFOs constructed. The construction of the TLM ports and TLM FIFOs can either be done in the component new construct or in the build phase method. Here, the UVM class reference reference has examples of constructing port and TLM5 is a component to new construction for example section 14 TLM interface port and export and transfer interfaces and section 16 analysis port. And in the build phase, for example section 14 blah 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 and same example. Aside from the port, all components are built in the build phase method to allow runtime and the build uh, uh, allow the runtime and this factory grab and creation of the component register with the factory. And since ports and TLM5 ports are registers with the factory, they do not have to be created in the build phase method. That being said, we prefer new construct ports and FIFOs in the build phase of a component. We believe in more sense and pool all building the factory selected components as well as ports and FIFO, TLM FIFO components in the single place for easy examination. The next is remove. Let me continue. Removing new construction of ports and FIFO, TLM FIFOs from the construct also means that 90% plus 90% and more of the component construct can be the same identical and borrowing 3 lines of new construct code. In short, it does not matter the portion of fibers are placed in the component new construct or in the component build phase, but we prefer to put them in the build phase. Okay. Next section is the 5.3 UVM owners import usage options. When terminating an analysis path, there are 3 options. Option 1 is explicitly declare the UVM underscore analysis imp port inside a component. This option has 3 important requirements. Unlike UVM analysis port and UVM analysis export port declarations, the UVM analysis imp declaration requires 2 parameters, transaction type and the name of the class where the UVM underscore imp is declared. 2. The UVM
analysis imp must be built in either the build phase, our reference preference, or in the component new construct. The class with the UVM underscore imp underscore imp declaration must override the right method and then provide an implementation for the same method. Okay. The option 2 is to declare the component that is extension of a UVM subscriber base class. This alternative would include a pre-declared and constructed UVM underscore imp. The user is only required to override right method and provide an implement for the same method. The UVM subscriber is described in section 6. Option 3 is to declare and build the UVM underscore TLM underscore analysis FIFO and then connect the FIFO to a UVM analysis export on the component. The FIFO has already pre-declared UVM analysis import with a corresponding write method to store its foundation into a UVM underscore TLM underscore analysis of FIFO. Okay, let's go to the chapter 6. A UVM subscriber. UVM subscriber base class is appropriately named. A subscriber is connected either directly or indirectly to a UVM underscore analysis port and provide the right method required by a UVM underscore imp. 6.1 Pure virtual write function. The pure keyword is only legal in a virtual class. A pure virtual method is a method that is only prototype in a virtual class, only the method header, and require that extended class actually provide a method implementation, and the UVM subscriber virtual class includes a pure virtual write method. Any class that extends the UVM subscriber must not override the write method with an actual implementation. 6.2 Multiple UVM analysis input ports on the same component. Each UVM analysis input requires a function called write. When there are multiple UVM analysis imps on the same component, each must have its own write method. But of course, each component's class scope is only allowed to have one method named write. So what can be done if more than a UVM analysis input requires the same component? A solution to this problem is shown in section 9. Okay. Next. 7. System value mailbox. The system value language added to mailbox keyword and the mailbox is a special type of system value queue or FIFO that is very useful in the verification environment. A circular queue is sequentially accessed memory with write and read pointers that wrap back to the zero, and the queue depth is reached, thus allowing the reuse of each memory location as the pointers wrap back to the location zero. FIFOs are circular queues are designed with a fixed number of addressable words of entries. FIFOs are full and empty flags to indicate when all of the available locations have either been filled or all of the available locations are empty. Okay. Stem value could have a bounded size like a FIFO or be bounded in size, which is the default. A system value Q can be manipulated using Q-specific algebra and system value, or they can be manipulated using CQ-specific built-in method. Okay. 7.1 Mailbox versus Q. System value added both queue and mailbox dynamic types, which did not previously exist in Velar. As will be described later, the UVM underscore TLM underscore FIFO and UVM underscore TLM underscore analysis FIFO both use the mailbox and not the queue, because the mailbox offer an important blocking feature that are used in the UVM scoreboard. Both queue and mailbox can be declared to be unbounded, which is to say that both can hold an unlimited number of entries, and both can be declared bounded, which is to say declared can indicate the maximum number of entries allowed in each. And both have put and try put method, where the put method is a built-in task and try put as a built-in function. Since a queue or mailbox can be bounded, queue or mailbox is bounded, they might be forcing the put command to block for a period of time until the queue or mailbox has space to allow a new entry to be added. When a corresponding get or try get has removed an item from the queue or mailbox, then try put command is a function that completes in zero time by either successfully placing a new item on the queue or mailbox and returning the status that the try put command succeeded. Then the try put failed because the bounded queue or mailbox is already full, in which case the try put command return a failed status of zero. If the queue or mailbox is unbounded, both put and try put commands will always succeed, with the only difference being that the try put command will return status and to indicate the try put operation succeeded, returns a positive value of 1. Try-put method can be called by either a task or a function, since it completes in zero time, while the put method can only be called by a task, since put commands might block and consume simulation time. Okay. So next is the TLM 5 TLM 5 Chapter 8 TLM 5. There are two types of built-in TLM 5 in UVM. TLM 5 UVM underscore TLM underscore 5 described in section 8.2 and a UVM underscore TLM underscore analysis 5 described in section 0. Both of these TLM 5s are derivatives of the TLM underscore UVM underscore TLM underscore 5 underscore base class, described in section 8.1. TLM 5s are described in section 8.1. TLM 5s are variable synchronization structures that are commonly used in UVM, especially in scoreboard. We find the TLM underscore analysis 5 to type typically be more variable in UVM score. Yeah. 8.1 UVM underscore UVM underscore TLM underscore 5 base. This base virtual class in the UVM base class library is here to find 4 ports, a build phase method, and 17 additional virtual method. The purpose of the 5 base class is UVM TLM 5 base class is reserved method prototypes to be used by the UVM TLM 5. extended from the UVM type UVM TLM54 base, and the UVM TLM analysis 54 extended from the UVM TLM 54. Although rigor, verification engineers typically do not extend UVM TLM 54 base class. Oh, okay. The figure 10 UVM TLM54 base ports. Now, as can be seen in the figure uh, 10, the FIFO base class has two input ports and two output analysis ports. The input ports have many aliased names while the output UVM analysis ports and only have the name get AP and put AP. The port types and analysis names for those ports are shown in Table 1. The reserved method names and notes about method implementation are shown in Table 2. Table 1, UVM TLM FIFO base, port name and port name aliases. Port type, UVM put input, port name or alias, put port, blocking put port export, non-blocking put export. Port commonly used in UVM TLM 54 or UVM TLM analysis 54. UVM get peak input, so many port analysis, and UVM analysis put AP and get AP. And TLM2 table 2 UVM TLM54 base method and usage note. Virtual empty method put get pick put get pick can put get pick try put get pick can put get pick build fade flush okay to put get pick is empty and full side and used. Hmm. And virtual empty method note native mailbox method implemented by UVM TLM 54 implemented by UVM TLM 5 analysis 54. Okay. Next chapter is 8.2 UVM TLM 54. The UVM TLM 54 can be used in UVM scoreboard design. UVM's TLM54 is internally built using a system value mailboxes defined is internally built using a system value mailbox and is defined with a default depth of just one transaction, which is nearly useless. But this can be changed and is almost always changed when the UVM TLM54 is new constructed. The UVM 8.2.1 UVM TLM54 new construct and size. The new constructor from the UVM TLM54 takes the three arguments: name, parent, and size. The size argument has the default depth of 1. Setting the size argument to 0 causes the U. The setting the size argument to 0 causes the UVM TLM54 to have unbounded depth, and setting the size 0 is generally recommended for scoreboard designs. Note: The UVM analysis TLM analysis FIFO described in section 0 has default size already set to 0, which is generally either for verification purposes. Okay, the TV scoreboard, the example 15 declare the UVM underscore TLM FIFOs to hold expected and actual transactions. Both are new, constructed with the unbounded size value of 0, and both are written to using void-casted triple method. The write PRD, the write predictor, method also takes a copy of the broadcasting transaction before predicting and storing the correct output values into the expected transaction (ETR). ETR? Where is the ETR? Okay, ETR. Class TV scoreboard stands the UVM scoreboard, and there is a FIFO and the unbounded tail and FIFOs. An ETR create a copy of the TR object and avoid their tripod and the write predictor and write out and long phase forever the export to FIFO get out FIFO get. So 8.2.2 UVM TLM FIFO put and tripod method. Since the Since the UVM TLM54 is extended from the UVM TLM54 base, the UVM TLM54 has two input ports and two UVM analysis ports. Although it is possible to connect to any of these ports, they are frequently left unconnected in a scoreboard design. The put and try-put methods store transactions into UVM TLM54 mailbox. These commands also broadcasting the same transaction out of the put AP as shown in figure 11. The put underscore AP UVM analysis port is rarely used. Setting the UVM TLM54 size is 0 to means that the put and try-put method both automatically succeed, with the latter remaining a status value, which will always indicate that the try-put action succeeded. And generally, when calling a try-put method on the unbounded UVM-TLM50, a void cast is used to throw away the return values as shown in figure example 15. Since the right method are defined for a UVM analysis imp as a function, only the try-put method can be used to write the mailbox, even though both would succeed for an unbounded TLM54. The figure 11 UVM TLM5 put and get method behavior. 8.2.3 UVM TLM5 get and try get method. The get and try get method retrieve the transactions from the UVM TLM54 mailbox. These commands also broadcast the same transaction out of the get AP as shown in figure 11. Get AP on UVM analysis port is rarely used. Get is blocking task. The wait until there is a transaction in the mailbox of the UVM TLM50 to be retrieved. The blocking get command is ideal for use in a scoreboard comparator since it blocks until a transaction is available to retrieve. There is an equivalent blocking get method defined for system variable Q, which is why the TLM54 is a better choice instead of using a queue in a scoreboard competitors. Engineers who try to see a queue in a scoreboard competitor typically have to either do sampling or use the event triggers to wait until there is a queued transaction that can be properly extracted. 8.2.4 UVM TLM54 disadvantage. Placing a UVM TLM54 into analysis path has a disadvantage that a scoreboard must somewhere implement a UVM analysis imperate method to receive a broadcast transaction and thus avoid a try-put ETR to store a transaction into UVM TLM54. The UVM TLM analysis file described in the next section removed the need to implement the right method execute to try to method command. Sorry, this is a footnote UVM TLM54, but one of the EDA vendors used to allow or may still allow the put method to be called from the UVM analysis imperate method. When a TLM54 was declared to be unbounded, because the method would execute in zero time and succeed, the other ED vendors properly disallowed the put method and it should not be legal to put in task from right function. We recommended that engineers do not use the put method with unbounded UVM TLM54, even your chosen vendor allow the operation. Okay, next one is 8.3 UVM TLM analysis of FIFO. This FIFO extends the UVM TLM FIFO described in section 8.2 and therefore inherits or parts of the capability of the UVM TLM FIFO. The UVM TLM analysis of FIFO has 5 ports. The same 4 ports defined in the UVM TLM FIFO as described in section 8.2, plus one additional UVM analysis imp port with a handle name analysis expert, shown in figure 12. The 4 UVM TLM FIFO inherited ports are rarely used in scoreboard. That means it is used. The analysis FIFO, that UVM TLM analysis FIFO is this is a figure 12 UVM TLM FIFO analysis FIFO, most common usage here. And UVM TLM analysis FIFO is ideal to store transactions that were broadcasting from a UVM analysis port. Within the analysis path, the UVM TLM analysis FIFO has two distinct advantages over the UVM TLM FIFO. First one is by default, the UVM TLM analysis FIFO has unbounded size, which is perfect for UVM score environment. And the UVM TLM analysis FIFO has a built-in UVM analysis input port with the corresponding write method to store the broadcast transaction. Unlike the UVM TLM FIFO, the UVM TLM analysis FIFO has an extra UVM analysis input port that must be connected inside of the scoreboard. Section 8.4 describes and graphically shows the differences between using a UVM underscore TLM underscore FIFO versus the UVM TLM analysis FIFO and the scoreboard design. Okay, quick summary 8.4 of UVM TLM analysis FIFO versus UVM TLM FIFO. Most UVM scoreboards are efficiently implemented using unbounded TLM 5.0. The UVM TLM analysis 5.0 is unbounded by default, which is perfect for scoreboard development. UVM TLM 5.0 must be new constructed with size 0 to become unbounded. This is a minor advantage to using UVM TLM analysis 5.4. The biggest advantage of the UVM TLM analysis 5.4 over the UVM TLM 5.4 is that UVM TLM analysis 5.4 has a built-in UVM analysis input port with a corresponding built-in writing method to capture transactions were broadcast from an analysis port. This is an extremely useful advantage of the UVM TLM 5.0 and saves a great deal of work in developing a UVM scoreboard. Figure 13: UVM TLM 5.0 versus UVM TLM analysis 5.0 usage. These differences are shown in graph figure in Figure 13. Comparing the usage requirement of UVM TLM 5 UVM to the UVM TLM analysis 5.0 in a scoreboard, as shown in Figure 13 is described below. UVM TLM 5.0 TLM 5.0 is typically just 5.0 is typically requires declaration and construction of a separate analysis imp or a UVM subscriber with built-in UVM analysis imp, and requires implementation of corresponding write method, which uses a void try to put call to a store transition to UVM TLM 5.0. Of course, the separate TLM 5.0 must also be declared and constructed. 2. The UVM TLM analysis 5.0 typically requires declaration and construction of a separate UVM analysis export and the UVM TLM 5 analysis 5.0. The analysis export port is then connected to the UVM TLM 5.4 analysis 5.4. The UVM TLM analysis 5.4 already has the required UVM analysis input and corresponding write method. Okay, next one is section chapter 9, UVM analysis input declared SFX macro. The SFX suffix. If there are multi-UVM analysis imps in a component, the user must define multiple uniquely named UVM analysis imp SFX port with the corresponding write FSX method. UVM has a macro to define a UVM analysis imp port with a unique port suffix names and unique write method suffix names. The macro is UVM backward UVM analysis input declared as fx. This macro is typically used for each UVM analysis input port on a multi UVM analysis input component. The first two lines of example 6 uses UVM analysis input declared as fx macros. The fxx values can be numbers or characters and can include the underscore as shown in this figure example or omit the underscore. This example uses suffix values of underscore PRD for predictor and underscore out for output. Using the backward UVM analysis in particular the SFX macros will define two new UVM underscore analysis port imp port types that must include the suffix values declared in the macros. In this example, the port types are UVM underscore analysis imp PRD and the analysis imp out. The macros also create two new write methods that must include the suffix values declared in the macros. In this example, the write method names are write underscore PRD and write underscore out, and these corresponding right method for the UVM analysis input PRD and the UVM analysis input underscore out ports respectively. Note that the UVM underscore analysis input underscore SFX handle names are not required to use the FXX values. But we believe it is good idea to use your suffix names as a part of handle names to reduce encoding confusion. Example 16 is about the TV scoreboard with the two analysis in particular the SFX macros, port and write method. 9.1. How many ports are allowed on the scoreboard? We have talked to the surprisingly large number of engineers who are under the impression that a scoreboard could have only one or two ports of any type, and they have to use the same transition type of two-port to variety. This is not true. Scoreboard can have any number of port exports and the approach can be parameterized into any number of transition types. It's true. Most black level, most block level scoreboards will only have one or more two input port types to sample a common transition to perform a simple calculation respective values to compare against the actual sample out values. But for large UVM environment, it is not common to have multiple ports that are parameterized into multiple transition types and then allow the scoreboard to perform a transfer function on one of the transactions before comparing specific field between multiple transaction types. UVM even has a UVM algorithmic comparator documented in the UVM class reference section 18.2 that is designed for this purpose. The UVM underscore algorithmic comparator is described as a comparator that compare two sorry compare two streams of transition. However, the transition streams might be of different type object. This device will use a user written transformation function to convert one type to another before performing a comparison. Uh, 10. 10. Section 10. Example with a typical analysis and copy problems. Consider a UVM test bench examples that appear to be working but that have hidden problems for a month. Once we discovered there was a problem, it still took hours to identify the cause and fix the problem. We want to help the reader to avoid the same time-consuming mistakes. You're welcome. We had a training lab that has a scoreboard with two UVM analysis input ports to demonstrate the multi-input port solution described in section 9. The write PRD method took the transition and calculated the respective output values and write them back to the transition and put them into the respective UVM TLM50. The write-out method is simply the transition into the actual output UVM underscore TLM50. The scoreboard comparison logic then compares the expected output to the actual output to determine if the simulation vector passed or failed. Once the test bench was working with both, we were done. Some months later, we decided to add a feature to the lab. We asked engineers to break the DUT, design the test, and observe the reported errors to see if they made sense relative to the bug. Much to our surprise, the test bench continued to report that the test passes. We broke the DUT more. The test bench will continue to pass. We traced the signal on the DUT. We traced the signal on the DUT signals on the DUT and noticed that the expected wrong outputs were being generated, but the test bench output continued to show and report valid outputs. We finally figured out the output PRDL calculated expected function was using the transaction input to modify the output of the broadcast transaction before putting them into an expected UVM under TLM50. This meant that the original transaction now had corrected outputs that had overwritten the current anonymous duty output, so the transaction that was put in the actual output UV underscore TLM50 had been corrected, and the test eventually reported no failure while showing the updated output values. This is why the inscriber that intend to modify the transaction should first take a copy of the transaction and use the input and copy the transaction to calculate the outputs to be placed back into a copied transaction. The guideline. Once the UVM test bench is working, break the DUT to see if the UVM test bench can catch the bug. This will show you if you have the same problem that we described in this section. Section 11 Summary and Conclusion. The UVM analysis port is a port that broadcasts transition to zero or more destinations, typically called subscribers. The end of each analysis path subscriber chain is a UVM analysis imp that must provide the implementation by overriding the imp's write method. Each component that subscribes to a common transition analysis path has a handle to a common transition. Any component that needs to modify any of the transition fields should first take a copy of the transition and only modify the field of the copied transition. This is the primary reason to have a copy method defined with the transaction. Fail to make a local copy of the transaction can have adverse effects on other components that reference the common transaction. Modifying the field of the analysis support broadcast transactions should never be done. With demonstration section 3.1.3.1.6, the most UVM analysis supports and the UVM analysis supports are interchangeable. Even though they are interchangeable, use analysis support for a component output that are forwarding to a transaction to other ports on the analysis path, and use analysis export or UVM analysis imp for a component input that are receiving a transaction from other ports on an analysis path. For scaffold developing, setting a FIFO size to 0 is generally recommended, and the TLM analysis FIFO described in section 8.3 already has that default size set to 0. If there are multiple UVM analysis imps in a component, the user must define multiple uniquely named UVM analysis input underscore SFX suffix port with the corresponding light map SFX method. This is most easily accomplished by using backward UVM underscore analysis underscore input underscore declared and parenthesis underscore open parenthesis underscore SFX close parenthesis macros to create a new analysis input port types with the corresponding write method. We mentioned that the UVM analysis input SFX handle names do not require the use of the SFX values, but we believe it is a good idea to use the same suffix names as a part of the handle names to reducing coding confusion. Finally, prove your scoreboard analysis tests are working correctly. When the UVM testbench appears to be working, break duty to see if the UVM testbench can catch the bug. This is a good correctness indicator for your UVM testbench. One of our paper viewers, Jeff Arnold, mentioned another option that he had seen in practice that is worth considering. We described the use of UVM subscriber in section 6. Another option is to declare multiple UVM subscriber instances inside a component. That is, in the scoreboard declares an array of subscribers and passes a handle to point to itself, the scoreboard, to each subscriber. Then each subscriber can have extended write method that push the transaction to the scoreboard queues. The advantage being all these port connection details are encapsulated and is easy to address or easy to add or remove connections by just adding removing subscribers, but requires defining understanding subscriber classes. We thank Jeff for sharing this interesting technique. We did not have time to try this ourselves, but it certainly appeared to be worthy technique. 12. Acknowledgement. Acknowledge our colleagues Jeff Vince and Kelly Larson and Don Mills, David Lee and Don Chaplin for their leaves and suggested improvement to this paper and the presentation slides. Their contribution helped identify the areas that needed additional explanation and modifications to the presentation slides, and they are ordering to make this difficult topic easier to understand. We are grateful for the insightful and generous contributions. There are reference and the reference 13 and 14 author and contact information. Last updated October 2018. Thank you for your time. Thank you.